In this lesson, I will be showing you how to apply the rules of differentiation to all the functions on your Leaving Cert Maths course. And your starting point for this is the tables, page 25, because all the rules are there. They're all listed. You can see here on the left, we'll start off with these ones. So all these functions, when differentiated, will give you these results here. And I'm going to go through them one by one. So let's go through the first one here, this x to the power of n. So if we just take some examples straight away. So the first example would be a function like y is equal to x cubed. And if you get the dy dx of that, so the dy dx of that function, the rule is very simple. The power comes on in front, whatever that power is, it comes down in front. So it's 3, and it's x, the power goes down by 1, so it's 3x squared. And that's it, that's the rule. That's what this rule means. When there's a power, n, it comes down in front, and it goes down by 1, n minus 1. So the examples are the best way to understand this. Y equals x to the power of 3 becomes 3x squared. Or another example, y is equal to x to the power of 4. dy dx is equal to, the 4 comes down in front, so it's 4x cubed. One more, just to get the idea. X to the power of 5, dy dx is equal to, 5 comes on in front, so it's 5x to the power of 4. So that's the first rule, really. Don't forget some of the less obvious ones that can be used with that rule as well. So, for example, y equals the root of x. That doesn't look like the same rule, but in reality it is, because, of course, y equals root x is the same thing as x to the power of a half. And now you can use the rule. So dy dx, the half comes on in front, x to the power of, and you reduce the power by 1, so it's a half minus 1, which is minus a half. So the rule still applies. If you had y equals the cubed root of x, well, of course, cubed root is the same as x to the power of a third. So dy dx, the third comes on in front, x, and you reduce the power by 1, so 1/3 minus 1 is actually minus 2/3. There are some others that you can use with this rule. For example, you could use even x itself. Think of x itself on its own. Well, that's really x to the power of 1. And you can use the same rule then. dy dx, the 1 comes down in front, x, and you reduce the power by 1, so it goes to 0. So you end up with x to the power of 0, which is actually 1. So in the future, when you differentiate y, or get the dy dx of y, it's equal to 1. At this stage, I need to emphasize as well, of course, the other notation. There's another way of saying all of these. You could say f of x is x cubed. Take the first one again, go back to the first one. And instead of saying dy dx, you could equally say f dash of x. It's the same thing. F dash means differentiate as well. It's 3x squared. And the second one, again, fx is equal to x to the power of 4. So the f dash of x is another way of saying the same thing, is 4x cubed, etc. The same for them all. So it's just two ways of saying the same thing. As a matter of fact, in the tables, that's the one they use, fx and f dash x. Now, we'll stay with this for a while. We're still on the first rule there, because you now need to be able to, I suppose, join those together. And I'll show you what I mean by that. Some more examples. So if you had y is equal to x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x, for example, dy dx is equal to, the 4 comes on in front, so it's 4x cubed. You just do them all individually. And that's then 3x squared. And that's 2 comes in front, x to the power of 1. X goes down, the power goes down by 1. So I'm just using the same rule for each of them individually. You do them one at a time. That's all you have to do when there's pluses or minuses in between. And x on its own goes to 1, as we saw on the last page. So that's how you treat something like that. Now, some more rules. If you had y is equal to, so constants. Y equals, for example, y equals 5. It turns out that dy dx is not. So you can just accept that as a rule. Any constant on its own, dy dx is not. That's because the whole point of differentiation is you're differentiating, it's basically the rate of change of something. And if something is constant, that's the opposite of change. It's not changing at all. So the dy dx is not. So that's what dy dx stands for anyway. And it doesn't matter what the number is. Y is equal to 8, for example, the dy dx is not. So you always get naught, basically. That's a rule in itself. So a constant on its own gives you 0. And watch out for the less obvious ones, like pi, for example. Dy dx is still naught, because pi is a constant. It's 3.14, whatever. Okay, so that's constants taken care of. Now, constants with x. So constants on their own give 0. But if there's an x with them, it turns out the answer is simply 3. So dy dx in that case is 3. Or if you had y equals 4x, the answer is 4. Etc. So if you had y equals, for example, 2 pi x, the answer is dy dx is equal to 2 pi. So that's what you do with constants that are in front of an x, for example. If you have constants with a power, so all you do is the following. So y equals, for example, 3x to the power of 4. Well, dy dx, you just put down the 3. Put down the number as it is. So that 3 just goes down as it is. That doesn't change anything, basically. And then you just differentiate the x to the power of 4. So the 4 comes down in front. 4x and the power goes down. So you use the rule for powers with the x part, but the constant doesn't change. So it's 3. And now it becomes 3 by 4, which is 12x cubed. Another one, maybe y is equal to 4x squared, for example. Well, dy dx is equal to, the constant stays as it is, and it's just the x squared. The 2 comes down in front, so it's 2x to the power of 1. So it's 4 2s is 8x. So after a while, you cap on to the shortcut here. It's just 4 by 3 is 12. And the power goes down by 1. 2 by 4 is 8, and the power goes down by 1. So you can go to the middle step once you get used to this one. And now we can combine them all together. So some more examples. So you can take, for example, y is equal to 5x cubed minus 7x squared plus 2x minus 4. So let's just go along the line and apply the rule to each term individually. So the first one, well, as we saw in the last example there, the 3 comes down in front, the 5 stays as it is. So 3 by 5 then is 15. And the x power goes down by 1, so it's x squared. Same for the next one. The number stays as it is, minus 7. The 2 comes down in front. So 2 by minus 7 is minus 14. And then it's just the power goes down by 1, so it's x. Plus the last one. 2x, well, that just x because goes to 1 on its own, so and the 2 stays as it is, so it's 2 by 1, which is just 2. And minus 4 goes to 0, because any constant on its own then just goes to 0. Or minus 0, doesn't matter, same thing. So the final answer is 15x squared minus 14x plus 2. Another example, y is equal to 3x to the power of 4 plus 8x cubed minus 17x squared plus 2x minus pi, for example. So dy dx is equal to, well, the 4 comes down in front, so it's 4 3s is 12x, and the x goes down by 1. 3 8's 24, x goes down by 1 to 2. The 2 comes down in front, so minus 17 by 30 by 2 is 34. X plus 2x becomes just 2, and the constant goes to 0 again. So that's that rule done, really. That's all the stuff you can get asked on that rule. And we can move on now to the next one. So going back to the table, where are we in this thing? So that was the first one we've ticked off now. We've done that one. I might just go in my own order here. So we'll go to sine next. So we'll put the ticks on this side because we've done the x to the power of n now. We'll go on to sine x next as a function. And you can see in the table sine x goes to cos x. So sine x goes to cos x, so we'll just go to that one. So these are called the trig functions, trigonometry functions. So for the trig functions, we start off with sine. Y equals sine x. So dy dx is equal to cos x. So that's the rule for sine. Sine always goes to cos. If you had cos in, on the other hand, y equals cos x, well, the dy dx is minus the sine of x. So be careful with that, there's a minus. And finally, y equals tan x. It turns out that dy dx is sec squared x. Just a reminder of what sec is. Sec stands for 1 over cos. And that's it. That's the 3 trig functions done. Now we'll see for harder trig questions, we'll combine with other rules later, but that's how you get started anyway. And that's that one done. So they're much quicker to start off. So back to our table. Sine, cos, and tan are done now. The next function to look at is this function e to the power of x. And they're called the exponential functions. So this is a new one again. Y is equal to e to the power of x. Now it turns out this is an unusual function because it is the only function when you differentiate, when you get to dy dx, it's itself, it doesn't change. It's the only function that does that. That's the answer. Now, the only thing I'll say about that is not to mix it up with something else, which is a common mistake, and this is the mistake people make. Go back to the other one again, y equals x squared. What's dy dx? Well, the 2 comes on in front, 2x to the power of 1. The power goes down by 1. And people tend to use that same rule over here by mistake sometimes. What they do is they go, something like this, y dy dx is equal to the x comes down in front and it's e and the x goes down by 1. So they're using this rule over here for this because they see the power and they say, okay, that's the same power rule. But there's a big difference here. And the big difference is this. The x is in the power here, but the x is the main number here. It's the other way around. So the x is the main number here and there's a constant in the power. Whereas here it's the opposite. The constant is the main number, e is a constant, and x is in the power. So it's a different rule completely, and you can't mix them up. So we'll just about that because that's not the way to do it. Excuse me. So e is a special number, don't forget, like pi. E is a constant in maths. It's it's a number that turns up in maths. It's on your calculator. It's 2 points, whatever, it's 2 point something. And so watch out for e. It's a different rule completely. That's the only thing I'll say about that one. Now, there's another one that you can come up as well, where it's not e. E is a special number, as I said, but there can be another number, like, for example, y. There could be a number like a, some other number to the power of x, not necessarily the special number e. And that's a different rule again. If you go back to your tables, e is a is a to the power of x by ln of a, the natural log of a. So the dy dx of that is a to the power of x by the ln of a. So as I said, it's a new rule completely, and you might come across that sometimes, so just in case you do. So for example, if you had y is equal to 2 to the power of x, well, the dy dx of that is equal to 2 to the power of x. It's itself multiplied by the ln of 2 of the number itself, where ln stands for the log to the base e, of 2. Y equals 3 to the power of x, the dy dx is itself by the ln of 3, etc. Okay, that's the exponential rule. Now we're on to the log rule. And that's just a rule that you basically learn off as well, or we don't even have to learn it off, it's in the tables. So you see it here, ln of x goes to 1 over x. So we've done e now, we've done this. So we haven't done this one yet, actually, just skip that for the moment. So we're now on ln x, this one here. So log the base e of x. That's the same thing as ln of x. That's two different ways of saying the same thing, just to remind you there. The log to the base e of x, or the ln of x. And it turns out the answer for that is 1 over x. That's the answer. And that's all there is to that rule, really. It's just another rule you have to know. When you've log to the base e of x, it doesn't work for any other base, by the way. It has to be to the base e. This base number has to be e, or in other words, ln, which means the same thing. So it only works for ln of x. So that's that rule done. So back to our table again. So as I said, we've done that one. We've done ln of x now. Now we're down to the last three, really. The last three main rules, I suppose, which are sine, cos, and tan. So let's go to those, sine, cos, and tan. Inverse, sorry, what I meant to say is inverse sine, cos, and tan. So these are the inverse trig functions. So whenever you come across, for example, this y equals the inverse sine of x. So it's not the sine anymore, it's the inverse sine, or second function on your calculator. What's dy dx now? So in the tables, the way to define it is x over a. So when you go back to your tables, and you'll see what the answer is. It's 1 over the root of a squared minus x squared. So it's 1 over the root of a squared minus x squared. So that's the first one. Then there's y equals inverse cos as well. Cos minus 1 of x over a. So the dy dx is equal to, it's just a minus instead. So it's minus 1 up instead of plus. And that's the rest is the same. X squared, same as the inverse sine. So it's minus 1 over the root of a squared minus x squared. And finally then there's inverse tan of x over a constant a. I should have said this a just stands for any constant number. So it's dy dx is equal to 1 over the constant squared plus x squared. Sorry, it's a over x squared plus x, a squared plus x squared. So there's the three rules. They're all there in your tables, as I said. So that's these three here. Now, so let's do some examples on those then. So if you had, for example, y is equal to the inverse sine of x over 3. Well, according to the first rule there, a is now 3. So the dy dx is 1 over the root of a squared. Now a is 3, so it's 3 squared minus x squared, which is, of course, 1 over the root of 3 squared is 9 minus x squared. That's it, that's the answer. So we'll try another one. Y equals the inverse cos of x over 4. What's dy dx? We'll use the second rule. It's minus, first of all, minus 1 over the root of a squared. Well, a is now 4. So it's 4 squared minus x squared, which is, of course, minus 1 over the root of 16 minus x squared. And finally, y is equal to inverse 10 x over 2. Well, dy dx would be, so here it's this rule, so it's a over a squared plus x squared, and a is 2 in our example, so it's 2 over 2 squared plus x squared, which is 2 over 2 squared plus x squared, which is, of course, 2 over 4 plus x squared. That's it. If you go back to your tables, we now have all the rules covered. We've ticked them all off, apart from this one here, which we'll cover separately with when we're doing these three. So we have 3 more to do in the next video, the product quotient and chain rule. And this one I cover under those 3, basically, e to the power of ax. And so that's the end of the first lesson. So the next lesson, as I said, will be on these 3 here.